Have you ever looked up at the sky and seen those long white lines trailing behind an airplane? You've probably wondered, is that smoke? Is it fuel being dumped? Or, and you've definitely heard this one, is it something more sinister? You might have heard they're chemicals. You might have heard they're deliberately sprayed for some secret purpose. But what if I told you the truth is simpler than any of that, and at the same time, stranger than most people ever realize? Those lines aren't smoke. They're not chemicals. They're clouds. Man-made clouds, written across the sky at 35,000 feet. And the physics behind them reveals something remarkable about the atmosphere you're breathing right now. Here's the reality. A jet engine burns kerosene, Jet A1 fuel. When you burn a hydrocarbon, you get two main products, carbon dioxide and water vapor. For every kilogram of fuel burned, you get about 1.24 kilograms of water. Yes, more water than fuel. Now, at 35,000 feet, the outside air temperature is typically around -40 to -60 degrees Celsius. That's cold enough to freeze exposed skin in seconds. When the hot, humid exhaust, at over 600 degrees Celsius as it leaves the engine, hits that freezing air, something happens almost instantly. The water vapor in the exhaust condenses, but it doesn't just become a cloud droplet like you'd see at ground level. At those temperatures, it freezes immediately into millions of microscopic ice crystals. And those ice crystals are what you're seeing. A contrail, short for condensation trail, is quite literally a human-made cirrus cloud. Here's the part most people never think about. The exhaust also contains tiny soot particles, unburned carbon from the combustion process. Each one of those particles becomes a nucleus, a seed, a single point around which water molecules gather and freeze. Without those particles, the water vapor would have nothing to cling to. The contrail wouldn't form at all. Now here's where it gets interesting. You've seen it yourself. Some planes leave a trail that vanishes almost as soon as it appears. Others leave one that spreads, widens, and hangs in the sky for hours. Why? It comes down to the air the plane is flying through. Specifically, the humidity. If the surrounding air is dry, those ice crystals sublimate. They turn directly from solid to gas, and the contrail evaporates within seconds. Poof, gone. But if the air at that altitude is already near saturation, meaning it's holding nearly all the water vapor it can, the exhaust tips it over the edge. The ice crystals don't evaporate. They persist. And then something even more interesting happens. They spread. The surrounding water vapor in the atmosphere starts joining the party. The contrail actually grows, pulling moisture from the air around it. Given enough time and the right wind conditions, a single contrail can spread into a sheet of cirrus cloud, covering dozens of square kilometers. What started as a pencil line across the sky becomes a blanket. Scientists call these persistent spreading contrails, and they're a genuine subject of climate research. Because here's the twist. Contrails trap heat. During the day, they reflect some sunlight back into space, which cools things down. But at night, they act like a blanket, trapping infrared radiation that would otherwise escape. The net effect? Warming. And on a global scale, the warming effect of contrails may actually rival the CO2 emissions from the aircraft. Aviation meteorologists classify contrails into three types. Type 1, short-lived. You see these behind aircraft flying through dry air. The trail appears as a thin white line behind each engine, then dissipates within a few seconds to a minute. The ice crystals can't survive the dry environment. Type 2, persistent, non-spreading. The contrail hangs in the sky as a distinct line, but it doesn't widen. The air is humid enough to sustain the ice crystals, but stable enough to prevent them from dispersing. These are the ones that look like someone drew a chalk line across the blue. Type 3, persistent, spreading. This is the one that fuels the conspiracy theories. The contrail widens into a diffuse sheet, sometimes covering a significant portion of the visible sky. From the ground, it no longer looks like a line. It looks like a haze. And when multiple aircraft crisscross a busy air corridor, their spreading contrails merge. The sky goes from blue to milky white. That's not a chemical attack. That's just the North Atlantic track system on a busy Tuesday. Let's address the elephant in the room. You've heard the word chemtrails, The idea that governments or shadowy organizations are deliberately spraying chemicals from aircraft for population control, weather modification, or whatever the latest theory claims. Here's why the physics doesn't support it. First, altitude. If you wanted to spray something over a population, you wouldn't do it from 35,000 feet. At that height, any chemical would disperse over hundreds of miles, diluted to parts per billion before it ever reached the ground. The targeting would be impossibly imprecise. Second, volume. A 747 burns roughly 10 to 11 tons of fuel per hour. If you were loading chemicals into the fuel, you'd need tons of them, and they'd have to survive combustion at over 600 degrees Celsius. Most complex molecules don't survive that. They break down into simpler compounds: water, CO2, trace elements. Third, the people who would have to know. Every pilot, every maintenance engineer, every fuel truck operator, every airport worker across every airline in every country. That's millions of people, and not one has come forward with credible evidence? In aviation, secrets don't stay secret. We have incident reporting systems that log every minor anomaly. A global chemical spraying program would leave a paper trail the size of a mountain. So contrails are natural physics. But that doesn't mean they're harmless. I mentioned the climate impact, and it's real enough that the aviation industry is actively working on the problem. Research by NASA and the German Aerospace Center has shown that contrail formation depends heavily on the specific altitude and atmospheric conditions. And here's where it gets clever. You can often avoid making persistent contrails by changing altitude by as little as 2,000 feet. Just 2,000 feet up or down, and suddenly the air is dry enough that the contrail evaporates rather than spreads. Airlines are starting to experiment with this. They're integrating humidity forecasts into flight planning. A small detour in altitude could eliminate the warming effect of that flight's contrails entirely. And because persistent contrails form in relatively thin atmospheric layers, sometimes only 500 meters thick, avoiding them often requires a remarkably small adjustment. The engineering is also evolving. Newer engines like the Rolls-Royce Trent XWB and the GE9X burn leaner, producing fewer soot particles. Fewer particles mean fewer ice crystal nuclei, smaller, shorter-lived contrails. The next generation of engines, including hydrogen combustion engines currently in development, could eliminate soot particles almost entirely. So the next time you look up and see those white lines painting the sky, you'll know what you're actually seeing. Not smoke, not chemicals, not a conspiracy, just physics. The invisible moisture in jet exhaust meeting the invisible boundary of freezing air, crystallizing into something you can see. A cloud, written by an engine. A temporary signature of combustion at the edge of the atmosphere. And a reminder that even the things we see every day, the things we think we understand, hide layers of engineering and physics that most people never notice. If you love uncovering the hidden engineering behind our skies, hit that subscribe button. And here's a question for you. What's the strangest thing you've ever noticed on a flight? Drop it in the comments. We'd love to hear your thoughts. Thanks for watching, and welcome aboard Eureka Aviation. See you in the next one.